Hello, everyone. My name is Kelly Hall. I'm a marketing coordinator for ALS North America. I want to thank you all for joining us today for our Webinar Wednesday series. Our presenter today is Quenton Beals. Quenton has nearly 10 years of tribology experience and an OMA 1 certification from the Society of Tribologists and Lubrication Engineers. During his time at the Phoenix Laboratory, he has worked extensively in all operational areas, including customer service, sample testing, equipment repair, report diagnostics, and account management. During his time as a diagnostician, he diagnosed over 250,000 oil analyst reports and 45,000 aviation samples. Quenton helps support a diverse range of industries that include deepwater drilling, construction equipment, water utilities, and private aviation. Now, Quenton serves as the laboratory manager for tribology at our ALS laboratory in Phoenix. Today, he will be discussing the specialty testing of turbine oils. During this presentation, feel free to use your chat box, ask a question, or raise your hand features to ask questions throughout this presentation. All questions will be answered at the end. Quenton, thank you for taking your time to deliver this presentation today. I will go ahead and turn it over to you.
Appreciate it, Kelly. Thank you for that nice introduction. And thank you to all those that are attending live and then those that are going to go back and watch the recording. As you can see by the title, this is Intro to Oil Analysis with a focus on aviation oil analysis. Aviation Oil Analysis is a program that we support out of our Phoenix Tribology Laboratory. It's been supported there for over 30 years. So we have a long history of supporting that market and working with pilots almost on a daily basis. And as Kelly said, as my time as a diagnostician, I diagnosed over 45,000 individual reports and spent a lot of time chatting with pilots and mechanics for various aircraft. And I still do that to this day as a manager. So hopefully we'll get some good questions today and I can bring some good knowledge to why oil analysis is a good practice for pilots and for mechanics in the industry, and maybe offer some suggestions to how you can improve your existing program. So for who we are, ALS is ALS Tribology in of itself offers comprehensive oil, fuel, engine coolant, and metalworking fluid testing services across the globe. We have laboratories that spread across North America, South America, Australia, Europe, and we're expanding into new markets as well. ALS as a whole operates over 370 laboratories in 65 countries and employs more than 13,000 staff. So outside of tribology, we have divisions that work in food, pharmaceutical, geochemistry, life sciences, and in environmental work. So we have a wide range of resources and laboratories across all industries. And we are one of the largest independent analytical groups in the world. As I stated before, our ALS Tribology laboratory sites spread across Australia, South America, North America, Europe, and then even into the Asian region in Malaysia and Singapore. Mostly, though, the aviation oil analysis program is focused out of Phoenix. That's where we have dedicated staff that process those samples separate from our commercial samples. So what is aviation oil analysis? Many people that I talk to in my travels, when they ask what I do and I bring up oil analysis, I have to then further explain what we do. So there are many out there that oil analysis is a foreign concept. I use the analogy that it's kind of like getting your blood tested. You know, we go to our doctor, we want to make sure our health is good. And then I use that as an analogy for the industrial and mechanical side of the world is we do the same thing. We take lubricants, which is the lifeblood of those, and we test and try and diagnose and improve maintenance practices. So aviation oil analysis in of itself is a testing program designed for monitoring aircraft engines. We do receive samples outside of engines as well, so it's not solely centered on just aircraft engines. That's probably the majority of what we receive, but we do receive gearbox and hydraulic samples as well. So if you do have an aircraft that has a hydraulic system or a gearbox, for example, helicopters, we get helicopters from some police groups, Donald Douglas helicopters, for example. Some of those have gearboxes, and we test those. It helps you stay informed about any unusual wear, contamination, and lubricant characteristics. So those are the main three focuses when we're doing the analysis. We want to make sure that there's no abnormal wear. We want to make sure that there's no outside contaminants that are coming into the system. And we also want to make sure that the lubricant itself is meeting the specifications for what should be in that system. We provide updated histories of those results, and our information is provided with the sample. So as long as the hour information of the aircraft, whether it be on the airframe or the engine, we provide that on the report as well, and that helps serve as an additional record for you. Along with aviation oil analysis, we have a very comprehensive database of results and extensive experience in diagnosing those reports and results. As I said, within a few years' time, I was able to review close to 50,000 reports myself, and we have a wide range of diagnosticians that work at ALS. And as we work across different industries, we gain knowledge from each, and with practice, you gain that knowledge to be able to evaluate very effectively whether or not those results are good, if something's abnormal, maybe even how to be proactive about them. So what are some of the benefits that you might get out of aviation oil analysis? One, you're going to hopefully avoid catastrophic failures. Oil analysis is going to see the beginning stages of more progressive problems. So if it's a problem that a bearing, for example, is starting to fail, or maybe there's not enough lubrication occurring for a bearing surface, we're going to be able to tell that there's higher level of wear occurring, and you're going to be aware of that before that catastrophic failure occurs. Extending oil drain intervals is another positive outcome from doing oil analysis. One can tell if the oil still has positive qualities to it. Many times we get in a habit of changing oil solely based on what is recommended. And those recommendations are based on a very, very unique set of parameters. How long that aircraft has flown, how long are those flights, how was the engine ran during that flight, and for what period. So many manufacturers, they are going to be fairly conservative, and they're going to look at probably the most generic flying style when giving those intervals out. But many pilots might be more proactive in their maintenance. They might fly more conservatively. Other things that might come into play is extended downtime, where that might actually have a negative effect on the oil by letting an aircraft sit for a very extended time. So doing regular oil analysis will help you understand what's a good oil drain interval for you. There's a possibility that it needs to be shorter, and there's a possibility you can extend that. It's something that you can gain both on the aviation side as well as on the ground side of things with ground equipment. It also helps decrease maintenance time and costs. A lot of times with oil analysis, you're able to determine the source of that wear. And so instead of assuming what the problem might be and taking some maintenance acts and then hoping that that's going to fix the issue, oil analysis will help determine where that might be coming from. So understanding maybe what wear metals are appearing on that report, you might be able to determine that it's coming from the piston area of the engine. It could be an accessory drive that's wearing, and you'll be able to pinpoint that problem and maintain it correctly. And then it also reduce costs as well. So like I said, being able to avoid catastrophic failures, you'll be able to identify a problem and fix that problem before it's a catastrophic failure. It's far less expensive to do a minor repair than to rebuild an entire engine or gearbox. It'll also help you schedule maintenance more effectively. So once you are aware that there is a problem, it's really nice to be able to schedule that out ahead of time. Get that scheduled with a maintenance group. Whether they're busy or not, you might have an extended wait time, but the sooner you're able to schedule that, the sooner your aircraft can get back in the air. It also help increase the aircraft resale value. We receive many calls in the Phoenix laboratory of people doing a pre-buy on an aircraft, and they'll reach out questioning whether or not that the aircraft has had oil analysis done. So there is a tool to not only help you maintain your aircraft, but those that practice it when they're going to purchase possibly another aircraft, they might inquire whether or not that's been done. It's a good way to show that the aircraft has been maintained well, that maintenance was done proactively. It really gives a sense of confidence of somebody going in to pre-buy that aircraft, that it's in a good condition, it was maintained well, and that they're going to hopefully get a lot of extra life out of it as well. So we look at oil analysis as a small investment, but you get a large return. For those that are extending engines past their TBO, you can more confidently do that. I don't fly an aircraft personally, but I have a personal vehicle that has a lot of miles on it. And through doing oil analysis, I'm very confident that the engine that is in that vehicle is going to have a lot of extra life in it, where one might be concerned about how much longer it might last. I at least have confidence of that, and I know that aircraft owners are the same. We have many that are extending, past their TBO or OEM, recommended build time, and they use our oil analysis to do that. Helps you predict and schedule minor repairs. I kind of talked about this on the previous slide, but instead of doing a larger repair when a major failure occurs, you can identify the beginning stages of that issue and schedule a minor repair, and that highly reduces the parts cost and the labor time. Oil drain intervals as well. Oil isn't a huge cost, but it is something over the lifetime of the aircraft. If you're able to reduce the amount of oil changes per year by 1 over time, you will see some small savings add up from that. Helps corroborate with mechanic recommendations. This can be really important. Keeps everybody honest, which is nice. Instead of being told one thing and hoping that that's a problem, you can corroborate what issues might be occurring from the oil analysis. So, if the recommendation is that, it's maybe an accessory drive that could be failing, you can corroborate that with an oil analysis report and show that, yes, the elements that are on that report line up with these recommendations of what might be going on. So at the Aviation Oil Analysis Laboratory in Phoenix, we utilize ASTM methods to do this testing. The benefit to using an ASTM method is it's standardized. The method is standardized. You go to a laboratory in Australia and you have that test done, and then you come here to the United States and have that test done, you know that it's going to be done in the same manner. And ASTM methods have statistics within them that show what kind of quality you should get between laboratories. So they have what they call reproducibility limits and then repeatability limits. Reproducibility limits are between laboratories, and repeatability limits are within a laboratory. And as long as a good quality system is followed, you'll get some very high quality results from these methods. So one that we use in Phoenix is multi-element determination by ICP. ICP is inductively coupled plasma, and I'll talk about this a little bit later in this webinar. Multi-element is referring to the metallic elements that we're looking for, whether it be aluminum, iron, copper, lead, silicon. Some of those might be wear metals. Other elements that we look for could be contaminants, and this is how we determine them. So this is the measurement, as I said, of wear metals additives by atomic emission. The torch temperature on this is anywhere from 6,000 to 10,000 degrees Celsius. And to put that in perspective, that's very close to the temperature of the surface of the sun. It could be hotter, but it's a very, very, very hot instrument. Luckily, it's very contained. It's a very safe instrument to use. But it's very hot. And so what we're doing is, as we inject the oil through this instrument, it's essentially, for lack of a better word, burning everything that goes through it. And what it causes it to do is it excites all the atoms that are present, and each element, its atoms are going to emit a certain wavelength of light, which we're going to detect. So to put it in perspective, the sun's surface temperature is 5,500 degrees Celsius. And that's what the instrument there looks like. That blue glow in the circle that you see, it's very similar to almost like a welder's helmet, because that torch that's inside of there is plasma. And what we're doing is exciting argon with a very, very high voltage and radio frequency, and it excites that argon into a plasma that burns very, very, very hot. And then below that, you'll see some tubes, and those tubes will help direct that oil up through that plasma, and then it comes out as vapor out of that top exhaust port. And inside of that instrument, off to the right of where that torch is there is a Ccd camera sensor, and that's what's looking for those wavelengths of light. So we have it calibrated for very specific wavelengths, and these instruments are calibrated daily, sometimes multiple times daily, with certified standards for each element. So we're ensuring that when we report 50 or 100 ppm of an element, we calibrate to those standards to ensure that we're getting those correct values to you. Another ASTM method that we do that's fairly new for aviation oil analysis. In the past, we used to only do multi-element determination, but now we've moved into a lot of physical properties of the oils that we're testing, and total acid number is one of those. There's two different methods that it can be done by, D974 and D664. One is a potentiometric, which means that we're using a pH value to determine the acid value. And then one is by using a visual indicator. So we'll add it's kind of like a dye, and then as you titrate, it changes. That dye will change color, and we use that color change to determine how it works. And I'll kind of go through how this titration works. So the total acid number is the measure of the acidic substance in the oil by titration of potassium hydroxide to a pH endpoint. So in Phoenix, we use potentiometric, and what we're doing is we're adding the opposite of the acid. And so what we do is we use potassium hydroxide, which is it's a fairly basic substance. What we do is we add it to the oil, which is diluted in a solvent, and we're measuring the change in pH. So we're looking at how much of that basic compound it takes to bring it to a certain pH point. And from there, you can determine the opposite of that, which is the acidic substance itself. And this is a good way to determine the degradation. So an engine is a very harsh environment for oil. There's some applications in oil where that oil will last 20 years because it's kept very cool. It's kept away from oxygen. But an engine is a very violent place. There's a lot of heat. There's explosions occurring. There's chemical reactions happening where compounds are changing. You have nitration compounds occurring. You have nitrous oxides. You have all these acidic compounds that are getting into the oil. And what we're doing here is trying to measure how much of that acidic substance is getting into the oil, because that, along with being in presence of oxygen and heat, is going to accelerate the acidic buildup, and that acid is going to break down that oil. It's going to cause those physical properties to change, whether it's viscosity, so how thick that oil is, it could get thicker, and it's going to cause that engine to not operate at its best. It's going to impede the ability to lubricate that engine. It might cause it to run warmer than normal. And so looking at that acid numbers is very important to determine how healthy that oil is. And this is one of the good ways to determine how long you can use an oil. So if you want to determine, can I extend my oil drain, using acid number is a good way to look at, do I have some room and that oil take on a little bit more time being in that harsh environment. This is the instrument that we use to do this. All of those cups have a certain weight of oil added to them, and then that instrument will add a solvent into it. It will stir it, and then will then use a calibrated dispenser to dispense that potassium hydroxide into that mixture while it's stirred, and it's measuring the pH, and then we get to that endpoint. Another method that we do is viscosity, which is Astm D445. Viscosity is the resistance to flow. So honey, for example, has a higher viscosity. It has a very high resistance to flow until you heat it up. It might get a lot thinner when you heat it up. Oil's the same way. As it gets hotter, it gets thinner. Water, for example, has a very, very low viscosity, not a lot of resistance to flow. So we use this method to measure it. And it's the time for a volume of liquid to flow under gravity through a calibrated capillary tube. So a capillary tube is just a glass tube. It's calibrated with a known fluid, and we test fluids at either 40 degrees Celsius or 100 degrees Celsius, depending on the grade. SAE grades, their grades are determined by their viscosity at 100 degrees Celsius and ISOs at 40. So most aviation samples that are coming out of engines, we're obviously going to run at 100 degrees Celsius. It's very close to the operating temperature, and you'll be able to relate that back to the SAE grade of that fluid. ISOs, sometimes those are found in gearbox or hydraulics, and those will run at a 40 degrees Celsius to determine if they meet that grade. This is the instrument that we use to use that. In the kind of silver box that you see in the middle is a window, and inside of there is about 4 gallons of a silicone type fluid. So it's non-conductive, and that's why you can see some electronics in there. And those tubes are inside of that fluid so that they can be kept at a very constant temperature. So as you can see, there's a reading at the top left of that instrument that reads 40 degrees. There's actually 2 decimal points there. So we're reading, to the nearest hundredth of a degree, and that instrument's going to keep it very, very stable. We inject the sample, it's brought up to temperature for about a minute, and then it flows through those glass tubes, and there's 3 sensors down below that you can't see that are measuring how long it's taking for that oil to flow, and then that time is then calculated into a centistoke value. ISO 17025 is a quality standard, and it's something that I want to talk about because it's very, very, very important to us at ALS. What ISO 17025 is, it's a general requirements for the competence to perform tests and or calibrations, including sampling. It covers tests and calibrations using standard methods, non-standard methods, and components in the laboratory. So what this is a quality standard, and labs that are accredited to this get audited externally to ensure that the tests that they're performing are up to standards, that we're calibrating properly, that we're keeping all of the quality documents that we should, we're running statistical process control samples, that we're recording those, that we have everything documented, and that we're doing everything as the method states. We get externally audited each year to hold this accreditation. There's some labs out there that maybe don't hold an accreditation. What you can gain from that is they can essentially do the test methods as they see fit. It's not to say that they might not have a very robust quality system, But if they don't have the accreditation, no external body is verifying that, if that makes sense. So the benefit to having 17025 accreditation is an external body is coming in to validate that and accredit you to your quality system. And this is something that every ALS tribology laboratory in North America holds. So each one of our labs holds this accreditation and gets audited yearly for. As it states here, this might be repeating what I just said, but it's there to implement a quality system aimed at improving our ability to give you the best results possible in a consistent manner. So as I said, many of those instruments we're running calibrations either daily, maybe multiple times a day. We're running statistical process control samples where we have known values for those, and we run those sometimes every 30 samples. We want to ensure that when we're providing results to the customers, that the equipment is running at its best. I might kind of touch on this in the beginning, but there's those three fundamental areas that we do oil analysis on. One is wear debris, which detects the amount and type of elements from component wear. There's contaminants, so we want to make sure that there's nothing foreign in there, such as antifreeze, water. We want to make sure that there's no, dirt particles. We can see those in the spectrochemical analysis. And then we want to look at the fluid properties, making sure that you have the right viscosity grade. For example, if you're running an SAE 50 in your engine, we want to make sure it's still an SAE 50, that you're not, something hasn't happened to the oil that's caused it to be in the SAE 40 range, or possibly from acid buildup, it's gone up into the SAE 60 range, which then can cause problems. So some common wear metals that are found in oil are aluminum, chrome, copper, iron, lead, magnesium, nickel, and silicon. Magnesium is really only found in turbines, and lead as well. Lead's really hard for us to use as a wear metal in aviation engines due to the leaded fuel that's used. So normally when we do analysis, there's a lot of lead that's just there from the fuel that's being burned in the engine, and it masks any lead that we would normally see in a bearing, because lead is fairly common in bearings in the Babbitt material, and it is normally something that we would use to determine bearing wear, but that leaded fuel will mask that. So we really only use it for looking at bearing and thrust washer wear within turbines. But aluminum, chrome, copper, and iron are some major wear metals that are found throughout the engine, and we utilize varying patterns of these and what wear levels they are in conjunction with one another to determine where that might be coming from. For example, you might see high aluminum and high silicon, which would be a really good indicator of dirt. Maybe if you only had aluminum, you'd be maybe looking more at, if the engine is turbocharged, is it a turbocharger? And then when you get more combinations of iron and copper and chrome together, it really leads you to that top end of that aircraft. Additive elements is another way that we can ensure that you're using the correct oil. There's many out there that change their own oil, and so they know exactly what they're putting in it. Others might have a maintenance group doing it. But we can, if we're told what oil is in that engine, if it does have an additive package, we can compare that known additive package levels to the oil that's in your engine to ensure that you have the right product. So a lot of times when you do get a report, and we are reporting these elements, you'll see additives such as calcium, magnesium, zinc. Zinc is very common in gear oils as an anti-wear additive. And then if you're supposed to be using a mineral oil that might not have any additives, you would expect to not see any of these. So it's a really good indicator to know whether or not you have the right fluid. Some contaminants that you might see in your engine is water, naturally formed during combustion, but it's kind of a harsh environment, so it might evaporate, but it is formed in that combustion process. If it does get into the oil, though, it can cause foaming, additive depletion, and oil oxidation, as well as impeding how that oil and lubricate the equipment. Oil and water they don't mix well. They don't mix well. Fuel is another contaminant that we see often in engines. The main thing that it does is it causes viscosity loss. So you can think of it as maybe you have like a gravy and it has a lot of flour and it gets a little bit too thick, and you were to keep diluting it with milk, it would lower the viscosity of that gravy. So that fuel is doing the same thing to the oil. Fuel has a low viscosity, and as it mixes with the oil, it causes the viscosity to drop. And then with that viscosity drop, obviously the engine's going to lose its ability to lubricate properly. That's going to cause heat buildup, and then it's going to as well deplete the additives. And a lot of those additives are there to prevent oxidation and counteract acidic compounds. And so as you dilute those, that oil is going to degrade more rapidly. Antifreeze, a lot of engines could be water cooled, but those that may be using an antifreeze, if it does get into the oil, that glycol really does not like to mix with oil, and it will cause a sludge to occur and varnish. And so it's something that you really want to identify as quickly as possible, and that can be determined fairly quickly through the multi-element determination. You'll see, depending on what kind of antifreeze it is, you'll see sodium, potassium as some of the main elements present in those. Fluid condition, viscosity, as we talked about before, it's the resistance to flow. And as that oil degrades, normally it's going to thicken. It could thin out, obviously, with contamination, but normally it's going to thicken up. You're going to get sludge buildup, which is going to reduce its ability to lubricate. Viscosity is probably one of the most important properties of the oil. It's very specific for application, and once it starts to change, those, whether they're engines, gearboxes, hydraulic systems, they're designed very specifically, and the oils that are selected for those are done due to how those are designed. So once the oil starts to leave its viscosity range, a lot of bad things can start to occur. For total acid number, buildup of acid from combustion process, you really want to keep your eye on that. Obviously, when you're doing extended oil drains, you're always going to try to find that balance of not allowing too much acid buildup to occur. Another test that we're doing as well is PQI. It's ferrous metal content, where it doesn't matter what size it is. So the multi-element determination mainly focuses on smaller particles due to their ability to react very quickly in that testing process and emit those atoms. And so if you have larger ferrous particles, you might not get an accurate reading to the true quantity. So what we do is we have an instrument that utilizes a magnetometer, and it looks at the magnetic field, and we place the sample on that instrument, and it gives you a reading to the total ferrous content that might be in that sample, regardless of the size of the particles. So you can have a lot of very small particles or a few very large particles, and you'll be able to quantify that. So some common issues that we see from oil analysis results, probably I would say one of the most common is corrosion from extended downtime. On a lot of the calls that I take, that's a very, very common concern when a report comes back and there's elevated levels, mainly iron and aluminum. There will be a concern that something might be wrong with the engine itself. And a lot of times when I ask the question, how long has this aircraft been sitting? Most of the time it's been for an extended amount of time, whether it's a few months, maybe even a year that aircraft hasn't been flown. What happens is oxidation occurs inside that engine. Those surfaces, the iron surfaces, the aluminum surfaces, they're going to corrode, and the oil is going to leach that into itself. And when we test that, it's going to appear as that element. It doesn't matter if it's iron oxide or the pure form of iron. It's going to come up as iron when we test it. So it's very important that when there is extended downtime, that engine gets ran and that oil gets changed to remove as much of that corrosion as possible. And just be aware, if you do take a sample very soon after an extended downtime period, that you probably will see elevated wear levels. But normally we will make a comment as long as we're aware that there was extended downtime. Elevated wear metals when using additives, this is another thing that we've seen quite often where an additive such as CamGuard is added. And what happens is normally you have an increase in wear metals from that. And a lot of time it's due to the increased detergency of the oil itself once that additive is introduced to the system. And detergents, they're a good additive. They're really good for suspending particles so that they can be carried through the system, carried to a filter, and then when oil changes occur, that they can be taken out during that oil change. So they have very positive effects, and they can help clean out where maybe there's particles that have settled. But what occurs is if you haven't used that additive before and then you start using it, you'll see an increase in wear levels because there's more wear particles in the oil. It doesn't mean that there's something bad occurring, and it doesn't indicate increased wear in the engine. You're just getting increased particles suspended in the oil. Missing an inconsistent engine and fluid time is a tough one for us, and this kind of goes back into the extended downtime. When we don't know what the time is between the last sample and the newest sample we received, how much time is on that engine or how much time is on that fluid, it's very, very hard for us to diagnose those levels. If that engine had 10 hours on it with, maybe the levels that we normally see when there's 30 to 50 hours, there's a problem. But if we don't know that there's only 10 hours on that engine, it's very hard for us to not consider that maybe that's a 30 to 50 hour oil change that is maybe more common for that engine, and consider those normal levels. So it's very, very important that we receive from the customer accurate engine and fluid time. Proper sampling is really important. I wish I had a picture of an aviation focused sampling process, but this is one that I use frequently on a heavy piece of equipment here. And I'll bring up some examples of how this is related to real world calls that I've received from aircraft owners. But here you can see the mechanic taking a sample after the fluid is flowing over a piece of cardboard. What's not great about this is, one, there's a very large surface area where particles that are in the air, which inherently there's a lot of particles that are flowing through the air at any given time. Those are going to be able to settle on that oil as it's flowing, as well as that oil is going to absorb and start to carry any particles that might have been on that cardboard when he inserted it there under that final drive to take that sample. Now, things that I've seen happen on the aviation side is we received a sample once that had very high zinc levels, which concerned us. We didn't really know why. We didn't know if it was an additive in the oil. And what we determined was the mechanic had sampled it into a galvanized can. And that warm oil into that galvanized can had leached the zinc out of the can itself into the oil. Another common one I've seen is high silicon levels. Silicon is, normally from dirt. It can occur when a rebuild occurs and new seals. So if a silicone sealant is used, the oil will leach some of that silicon in, and we'll see that, for a few samples. But what can occur is somebody might use a silicone tube to take that sample and get it into the bottle. What occurs is that warm oil, as it's passing through an entire silicone tube, is going to leach some of that silicon into it. And when we test it, it might be at an abnormal level. So you have to be very aware of what might be occurring when you take that sample, what kind of contamination might occur in the process. So our data interpretation depends on establishing what's normal. So we have to know what's normal. It has to be taken in the same way each time. If you vary the way that you take your sample, there's no way for us to know this is normal, this is what we expect every time the sample comes in. This kind of goes into what I just said. Irregular sampling procedures can lead to false assumptions. A big one is running the aircraft before taking the sample. Those metal particles in the oil are going to settle. They're going to fall out of suspension and eventually settle at the bottom of the sump of that engine. When you take that sample, if you don't warm up that engine, that initial oil that starts to flow out is going to have a very, very high concentration of wear particles, which is going to appear very abnormal or severe in an oil analysis report. It's not representative of the engine whatsoever, but it's very hard for us to know that if that sample is not taken in a good, regular fashion. I said it can cause abnormally high, but it can also cause low values as well. So depending on where you sample in that stream, so if you were to sample at the start of taking that cold sample, you might have very high results. But if you wait till the very end, where it's the very top of that sump that's draining out, you might get some very low values, and so you'll get a false positive report that's telling you, hey, everything's awesome, when really it's not representative of what's occurring. Going into that, the false confidence can be dangerous. If you change the way you're taking that sample when a wear issue is occurring, you will not be able to identify it. So you will have false confidence in moving forward, thinking that everything is fine when there could be a problem. In reality, no sample is better than a bad sample. And it really comes back to that false confidence. We really don't want somebody to get a report that looks good because it was a bad sample and give that false confidence. If you can't take a good sample, don't take one at all. Do what you can to take a good sample. If you have to take it at a different time, a different day, you have to change your schedule for maintenance, and it's very important that you get a sample done right. Do that. Don't sacrifice trying to rush getting a sample just to get one, because if it's not a good representative sample, it's worthless. You've wasted your time. So representative means that it's typical of the fluid in use. So in reality, the best sample that we could receive is while that engine was running, that we could tap into the port right before it goes through a screen or a filter at the very end as it's gone through the entire engine, and take that sample straight out of the engine as it's running. That would be the most representative sample that we could. In reality, we can't do that a lot of times, and so we have to try our best to do that, which could mean running the engine until it's up to operating temperature, shutting it down, and then as soon as we can, draining that oil and taking it midstream. Some equipment, some might be able to add in a sampling port. Maybe there is a filter system on your engine. You can adapt a sampling port before the filter. It's possible. So as I just described, the best way is to take it while warm. It's not running, start it up, bring it up to operating temperature, and then take the sample. If you do have to shut it down to sample, do it within 30 minutes. You want to avoid as many of those particles precipitating to the bottom as possible. So for engine sampling, run it before you take it. You want to ensure the drain location is clean. That's very important. A lot of times oil drains can get dirty, they can have grime. You really want to make sure you wipe that off, because as that oil flows out, anything that can get pulled into suspension will. And do not open the bottle until ready to sample. Especially if it's a windy day, the wind is carrying a lot of particles through the air, whether it's dirt, probably mostly dirt, that can get into the bottle, and then we're going to detect that. Mid-drain is the best way to take a sample if you are taking it while draining the oil. The beginning of the drain will contain those large particles that will cause those abnormal results, but you don't want to take it at the end of the drain where a lot of those particles have precipitated out. So for sample frequency considerations, drain interval is probably the most consistent and easy way to do it. Is every time you drain the oil, take a sample. You want to take it at a reduced interval if you suspect there's a problem. So if you are a little bit concerned, maybe the engine's running a little bit different than normal, it's running hotter than normal, you've got concerns, take a sample. 25 to 50 hours is very typical for piston engines. Really depends on the make and model, oil sump capacity. Feel free to reach out to us. You can call us at the lab and ask us, and we can look in our system and see what's the typical drain interval that a lot of other pilots are using for that engine. Obviously, there's going to be the OEM recommendations as well. For turbines, it can be up to 100 hours plus. We're going to move into the sample information form. So when you purchase an aviation oil analysis kit, you'll get this form along with the sample. There's a lot of information that can be filled out here, and so we'll kind of work top to bottom. Aircraft registration number, the N number, it's kind of our universal way of identifying your aircraft. It's the way you identify it, the way it's registered, and that's how we like to do it as well. It makes it really easy when you call in. Our staff is very aware. If you know that you're calling in for aviation oil analysis, they're going to ask you for the tail number. So it makes it very easy. Aircraft make and model isn't as important. It's very good for record keeping, so we do like to have it and add it. There's a space for you to mark where you sampled it from, engine, transmission, or other. You can make a note there if you'd like, if it's a hydraulic system. You can mark the position, so we know that there's a lot of twin engine aircraft as well. So we give you the ability to identify what's the left and right hand side. The engine serial number is very important. We really like to get that engine serial number. The reason for that is we know that engines might get changed out in an aircraft itself. So while that N number might not change, the engine might change at some point. And the engine serial number is a really good way for us to not confuse a system, an engine itself, and knowing that that history is going to be kept together. So engine serial number is really great. So if that engine does get changed out at some point, and maybe that information doesn't get communicated to us directly, when we get that sample with the new serial number, we will know to create a new engine and create a new history. The engine manufacturer model is very, very important as well. That's how we really determine what's normal and what's not normal. Now, I do get a lot of questions about, what are the limits for each? And it can be difficult because each aircraft is flown very uniquely, but we do have general limits for manufacturers and models. And so we really like to have that information to know, to make sure that it falls within those. Then we're going to look at your time since new, time since major overhaul or total overhaul. So we really like those to get checked and provided. Hours on oil is very, very important as well. So like I said before, if you've only ran 10 hours on the oil, we really like to know that so we can look at those levels correctly than compared to one that might have 30 hours on it. Oil consumed is very good as well to know for us. So if you've added 2 or 3 liters of oil to that sump, we can then determine kind of how much it's been diluted. So if you've added in a couple liters compared to the total sump capacity, we can look at, are those wear levels normal considered how much oil has been added. Oil brand and type is then going to let us know, the grade. If there's an additive package, we can compare that and let you know that it's correct. The UIN, as you can see there, it says, if known, provide UIN. The UIN is a unique identification number that our laboratory uses for a sample point. So your engine is going to get its own unique UIN number. And if you know that can expedite the process. You can write it in there and we'll connect it. Usually the N number and serial number is highly sufficient. With that amount of information, we're going to be able to connect all the dots, but the UIN makes it a little bit quicker for our staff. It's one of the fastest ways that we can find sample points. So it does get printed on your report. So if you sample for the first time and you get that report, you'll have a UIN listed on it. You can then use that on your next sample. We really like getting comments as well. That's why we put that comment box there. whatever little thing has occurred, we really like to know. You know, if there's something you're concerned about, it's been, you know, temperature's been higher than normal, or maybe you had some work done, maybe, you know, whatever minor work might have occurred where maybe new seals were put on. It's really good for us to know. And then when we see that there's higher silicon than normal, and we see your comment that, oh, some work was done and there's some new seals, great. We can mark that as normal per your comments and send you a normal report. This is what our test report looks like. This is for our comprehensive test package. So as you can see, there's on the left-hand side, there's going to be your N number. There at the very top is going to be the UIN number that I described. So there's the UIN for the engine, that engine sample point itself. The N number is going to be listed as the unit number, and then there's going to be information about the aircraft, its make and model, what engine is in there, what serial number. If there's a known capacity, we can enter it in there as well. And then your customer information will be listed. Below that will be the diagnosis, and you can see here that there's an MPE wear debris analysis. And then there's further comments. So what they're saying here is that there's generally abnormal to severe wear rate throughout the engine. So it's almost throughout the entire engine. They're saying a very high rate of wear. Silicon levels abnormal, which could be dirt or sealant. The PQ index, which is the total ferrous material, is at a severe level, and but the viscosity is within specified operating range. So we know that the fluid's okay, but we have a very, very bad wear issue. Over to the right is all of the actual results themselves. So the most recent samples on the left, and as you go back in time, are the columns to the right. And as you can see, there's a pattern where the engine was running normally, and then the second to last sample, there was an increase in wear. So the PQ went up, wear throughout the engine started to increase, and then the next sample after that, it got far, far worse. The iron shot through the roof, a lot more chromium, and that PQ index went through the roof as well. So we know that there's a lot of iron and ferrous material that's being generated in this engine. As we move on to the back, there's going to be some graphs to let you know over time how these different main wear metals are changing over time. The first time you get a report, these will be blank because there's nothing to graph. So when you do one sample, you won't see anything. We have gotten some calls about that, but it's just because there's nothing for us to graph. So once you have multiple sample points, we can then graph them and give you these images. One thing that we do in Phoenix, though, is microscopic particle examination. So what we do outside of just giving you a report with numbers on it, this is a comprehensive testing kit that we now sell. This is something new that we've done within the past year or so. We do a microscopic examination of what might be occurring. So we use a special piece of equipment that makes the slide, and it has magnets to help align ferrous material. And you can see in the top left picture there that there's these it's in a vertical pattern. So you see a lot of up and down columns. Those are ferrous particles being aligned by the magnet. So it helps us know what's ferrous when we're looking at these particles. So all the ferrous material will be in the column, and then anything that's non-ferrous will be distributed in between them. Our technicians will look at this under the microscope and identify what's going on. So there's a lot of rubbing wear. So you can see, he could see at a very wide magnification that there was some rubbing wear, and then as he gets into a higher magnification, so 500 times for this top right and bottom left picture, he's identifying rubbing wear, red oxides, and also dirt. In the next one, which is at the entry as well, you saw some fibers, some black oxides, some copper, and then more rubbing wear. And if you look to your left, there's a diagnosis for it, and it says that there's heavy amounts of rubbing wear, predominantly low alloy steel, and moderate amounts of corrosives, which is usually oil additive depletion. Also present low amounts of black and red oxides, non-ferrous wear such as copper, and dirt and fibers. So what's interesting here is we heat treat these as well, so we can determine the alloy, and that really helps determine the source of where that wear might be coming from. So you can go back to the manufacturer and say, you know, this wear is low alloy steel or it's high alloy steel, and their engineers should be able to help determine better where that source of wear might be. Once the MPE is done, we do quantify these. So while we do a visual inspection and a visual diagnosis, we then at least quantify it as well, and we'll put it into a historical, into this historical pattern. MPEs were not run on the past samples because they are normal. I don't really highly recommend doing an MPE on samples that are normal. While you do get a lot of valuable information when there is an issue, it's a little overkill when you're doing normal sampling. So regular standard basic oil analysis is great for those normal samples. Once you start to see an issue, that's where that microscopic examination is really going to come into play to help determine what kind of wear is occurring. You know, what else is in there? Is there dirt? Are there fibers? Is there any other foreign contamination? But as I said, you can look at the wear mode. Is it rubbing wear? Is it cutting wear? Fatigue wear? It can really help determine, you know, how is this wear occurring? And then if you do multiple of those, you can quantify it and look at here over time. So performing accurate oil analysis, it's important to establish a baseline of new lubricant if needed. It's not always needed because a lot of times we'll have a baseline of that new oil. But if you're using semi-exotic oil, feel free to reach out to us. We can let you know if we tested it before. But if not, you can send us oil and we can test it. Use proper sampling labeling procedures. So it's very important that you fill out that form correctly, that it gets packaged correctly, that when we get it, we can truly identify which sample goes with which. There's been times where we've had two samples from a left and right engine placed inside of the same mailing pouch with no identification on the bottles itself. So the forms were filled out, forms were put into the mailing bag along with the two samples, but there was nothing on the bottles to let us know which was left and which was right. So it's very important, you know, if just as you're taking those samples and you're packaging them and sending them on, think to yourself, you have somebody that's opening these for the first time and looking at them, will they be able to identify what this is for? A common thing that we see people do is they write their N number right on the cap, even on single engine aircraft, even though the form is coming with it. It's really great. It's really great for us to know right when we open it, there's the N number. If we were to separate that form and that bottle, we'd be able to bring them back together. Sampling techniques is very important. As I discussed, timely sampling is huge. I have received a few calls where somebody has asked me, hey, if the oil has sat for 3 months, can you still test it? And yes, we can, but the concern is have you flown that aircraft in the past 3 months? And if you have, how long, you know, what value are you going to gain from testing that? You know, you're doing it to try and identify issues, not to just check off a box to say that you've done it. So when you take samples, package them up, get them to us so we can test them timely and get you back information so you can make any corrections that might be needed. It helps you adjust those preventative maintenance, as I just said. But the test packages that we're providing right now is, for many, many years, we've offered our standard or our basic test package, which is 7 elements for piston engines and 9 for turbine. So it's a very basic analysis of what wear metals are going on in your engine. We now have an advanced package which opens that up to 14 elements. So that starts to include oil additives and contamination. We're looking at viscosity, water, and PQI while doing that. The comprehensive package adds that microscopic particle examination. I believe it's missing, but I believe the advanced package also does that total acid number. So if you're looking to extend those oil drain intervals, the advanced package is going to do that acid number as well. And the comprehensive just adds on top of the advanced package that microscopic particle examination. So there's a way for you to get a fairly advanced package there where you're getting elements, viscosity, and tan without having to do that higher cost particle examination. Prepaid postage is now standard with all of our advanced and comprehensive packages, and it's optional with our standard kits. So what that is we send you a mailing pouch and the prepaid postage as well. So you just put it in the postage bag, you seal it, and all the postage is prepaid. You drop it in one of the blue USPS boxes, and it gets brought to us. The nice thing about that prepaid postage is it's first class mail, and it does have a tracking number. So feel free to take a picture of that tracking number to ensure that it gets delivered to us. And one new thing that we've started to do in Phoenix as well is we scan those tracking numbers when we receive them. So it kind of keeps everybody honest where, you know, when the Postal Service says that it's delivered, we're going to scan that packaging right when it's delivered into our own database. So we can refer back to every tracking number that we've received and then what sample was inside of that package. So it keeps everybody honest throughout the whole process. It's very rare for a package to get lost, but it has occurred. And so we want to make sure that when we get a package, we know that it's arrived. So definitely hold on to those tracking numbers. For data communications, we've got flexible notification lists. So if you have an aircraft that multiple people need to receive emails, we can do that. We can send out PDFs. We can send out summaries if you're getting multiple. Have our website, you can go on and download CSV files. So the PDF and summary reports, as I mentioned, the summary report is, let's say you're maintaining a group of aircraft and you send in 5 engine samples. Instead of getting 5 separate emails, you'll just get one summary report with a link to each sample. We can do email data files as well. So if you, like I said, you're running a large group and you want to get a CSV file that you can import into a database, we can automate that. Online internet access is a great way. We have our WebTrieve site where you can go on and you can add contacts, you can forward reports to them, you can download CSV files or XML files if need be. You can look at the reports on there. You can do trending. There's management reports. There's a lot of flexibility on our WebTrieve site. So yeah, I was just talking about WebTrieve. Like I said, easy access and management to that information. It eliminates any need for any third-party software, and it provides real-time analysis information. So almost, immediately from us finishing that information, it's going to be available on WebTrieve. You can access that at webtrieve.alstribology.com. And there should be a link there to sign up, and that will get our customer service connected to you to make sure that we connect you to the correct aircraft. And this is what the login page looks like. So username and password. If you don't have an account, there's a button there right below login that you click. If you do provide your N number when trying to register, you can, when we set you up, we'll make sure that you're connected immediately. Here's my contact information. You can email me directly at quenton.beals@alsglobal.com. You can phone me at the lab directly, or you can even come in and visit. We have some pilots locally in Arizona that come and drop off their samples. If we're not too busy, we can, if you even want to come and see some of the, how we do some of the testing, we're always happy to have visitors come in and have us be transparent on how we're processing samples, things that we're working on, things that we're trying to do to improve the aviation oil analysis program. All right, well, I'm looking forward to hopefully some questions.
Yes, thank you, Quenton. We will go ahead and open it for questions. If you would like to ask your question directly, feel free to use the raise your hand feature and I can unmute your line and you can ask that question to Quenton. We also have the chat box or even the questions box. Feel free to write out your question and I can ask it directly to Quenton as well. We'll go ahead and take a few moments for everyone to gather their thoughts and possibly have a question in mind. I did want to let everyone know that we do record these webinars and we do post them on our YouTube channel as well as online on our website. We do have a question coming in from Ed. He asks that on the example report given, I noticed that the lead was really high. Is that from the fuel used?
Yes, that would be from the leaded fuel that's used. That's correct.
We had another question come in from Martin. He asks, the oil drain interval you mentioned is based on an OEM spec?
A lot of times, yes. So it's hard for us to have all of the OEM specs, on file. A lot of times the OEMs will keep things close to their chest, and it's hard for us to manage a lot of that data. But just from what we've seen, a lot of the intervals that we see occurring, that's kind of what we use to suggest to others because we only assume that everybody's following the OEM recommendations when doing that, 25 to 50 hours.
I don't see any more questions coming in. While we wait for anything else that might need to come through, I did want to let everyone know as well that to follow our showcase page on LinkedIn. We post links to future webinars and other valuable resources there. And again, we do post this on our ALS Limited channel on YouTube under our North American playlist. We just have some comments saying, thank you, Quenton, for this information today.
Oh, I appreciate it. No, I really appreciate everybody's patience. Kind of went longer than I expected. I really get going there. So thanks everybody for staying tuned to this.
Yeah, it doesn't look like we have any additional questions. So I do want to thank everyone for attending our Webinar Wednesday series today. Thank you again, Quenton, for presenting, and hopefully everyone can enjoy the rest of their week.
Yes, thank you everybody.